Okay, guys, we're going to start out chapter 10, or sorry, unit 10, which will be focused on eventually, hopefully, finding derivatives. So you're ready for calculus next year. But we're going to start out the unit, by reviewing slope. So this will be pretty quick. I don't anticipate that a lot of you are going to have trouble with this, but I want to just take a minute and review what it means to have a slope. Okay, so if you think back to your, Algebra 1 days when you first introduced the word slope, there were some ways that you could describe what slope meant. Some of you maybe most remember hearing the phrase rise over run. Some of you may remember change in y over change in x. Some of you maybe even remember the formula, which we'll write up here. But if you don't remember the formula, that's okay. We can find slope without it. And some of you maybe have seen this notation, delta x. And that'll be something that if you do take calculus, you'll see more of. Those are just a few quick review, like ways of naming slope. It's the steepness of the line. Lots of different words that we can use there. It's also the rate of change of your line, which is an important one for calculus as well. These two are what you'll see when you get to calc. How do you find it? You think about either your change in y divided by your change in x, or you can use the formula. So we'll look at finding slope two ways, by either counting on the graph or by using the formula with 2 points. So the steepness of a line can be found by doing, your slope triangles you might remember from Algebra 1, where if you locate, 2 points on your graph, so maybe on this first graph, there looks like a nice point, and then maybe right here, there's lots of different places, maybe right here looks like a nice point. And if you remember, you drew in those slope triangles that connected those 2 points, and really slope is just, the formula for slope is just a shortcut really for using Pythagorean theorem in a way. But our slope is how much we go up or down, and then how much we go right or left. So we go down 5, so we have a downward movement of 5, and then we go right 4, so we have a forward movement of 4, and our slope is just our rise over run. So in this case, we went down 5 over right 4, and that's our slope. Okay, pause the video and try B, and then come back and check when you're done. So maybe you found it this way, in which case your slope would have been up 6, right 4 for a slope of 6 over 4. Now that can be reduced to 3/2, and some of you maybe would have found it a different way, and I'll show you that here. So maybe you just chose a different ending point, same beginning point, but maybe you noticed this point 2, -2, and chose that instead of choosing the point 4, 1. Okay, but either way, we're going to get the same slope if we simplify it, and that's the key. So whatever you find for your slope, make sure you put it in the lowest terms for that fraction. Okay, so graphically pretty easy. Now let's find the slope between 2 points. And as I said, there's a formula you can memorize, or you can just remember the idea that we're talking about the change in y, the difference in y. So the difference between the y's divided by the difference between the x's. And so if you do that, then it's a really easy thing to remember. I just take my y's and I subtract them. So I would do 12 minus -7 over, sorry, had to change ink there, over my difference in x's, so that's -6 and 4, so -6 minus 4, and then you simplify. 12 minus -7, well that's adding 7 really, it's 12 plus 7, so that's 19, over -6 minus 4, which would be -10, and our slope is 19 over -10. Or you can write that as -19/10. Or you could even write that as negative and then 19/10. All three of those mean the same thing. Okay, try B and come back and check your work. So depending on which way you went about doing this, you may have subtracted using the first point first or the second point first, and I have both of those up there. But again, either way, you should get 77 over 131. All right, so when you actually start talking about calculus, it focuses a lot on this idea of the rate of change or slope of functions. We're looking at sometimes instantaneous rate of change, in which case we're looking for the rate at which a graph falls or rises at a single point. And the way we best approximate that is with what we call a tangent line. Now, just like with circles, tangent implies that it sort of bounces off the outside of the circle with the tangent line. Same thing with graphs. It's going to bounce off our graph. So when you look at each of these tangent lines that are in pink graphed below, you can sort of see how this tangent line bounces off of the actual function. What we're going to do is we're going to say that the rate of change at point P is whatever the slope of that tangent line is. So we know how to find the slope of a line. It's just finding where that tangent line is that might be a little tricky. It's possible that for one function, for a nonlinear function, if I choose a whole bunch of different points on that graph and ask you to find the slope at each of those points, you're going to see a bunch of different possible slopes. So depending on the point that you choose to draw your tangent line, you could have a completely different slope from one place on the graph to another. And really what it's measuring is how fast is that graph either going up or going down at that particular point. So when you look at, the steepness of this function right here, it's falling pretty quickly. So the slope of your tangent line is going to be falling pretty quickly. Right here, it's sort of leveling off a little bit, so it's not falling quite as quickly. So you'll see the slope of your tangent line be less steep. And then here it starts to pick up again. So the slope of that tangent line is a little more steep. The thing about tangent lines that's interesting is that when we're visually trying to draw them, it can be a little tricky. And that's the only thing we're going to practice with in this little section here. So if we want to find the slope of a graph at a particular point, we're going to draw in the tangent line and we're going to estimate the slope. That's the hardest part, is drawing in that tangent line. So let's say I want to find the approximation of the slope of this function at the point 1, 1. So here's the point 1, 1. What I have to do is estimate where that tangent line is going to be. Now when you do this on Delta Math, it'll be a little more guided and you'll be able to get a little more precise. But when we're talking about on paper and pencil, it is literally just going to be an estimation. So I may, just estimate that, hey, that sort of looks like a good tangent line. And in which case I can draw that tangent line in, and then I just find my slope of that line doing any process that we've done in the past, like slope triangles. So maybe to find the slope of this tangent line, I go from here, I don't know, to here. Those 2 points look like they might work out well, and we're just estimating this slope. So this goes up to and right 1. So an estimate of my slope would be rise 2, run 1. It's an estimate. You might get something just slightly different. It's okay if you do. We're just estimating. We're going to eventually get to a place where we can find it more precisely, but for right now, we're just kind of guessing. So why don't you go ahead and try this one? Just get a tangent line in there as best you can. Remember, it sort of bounces off the function at that particular point, and then estimate the slope. Just an estimate. Don't worry if it's not the same as what I'm going to put up here. You just want to make sure your line looks similar to mine. So pause the video, see if you can draw in a tangent line and estimate your slope. So your tangent line should at least look similar to mine. When you talk about the slope, make sure you pay attention to scale. This graph is vertically counting by 2s and horizontally counting by halves. So I'm actually going up 4, right a half here, which I have written as my slope. And then remember, we want to simplify as much as we can, and that would simplify to 8/1. If you are anywhere, as long as you have a positive, sort of steep slope, then you're fine. Okay, go ahead and try out a few problems on Delta Math just to get some practice with slope.